Okay, let's get started, everyone. This is Eric Andelin, Senior Photogrammetric Workflow Specialist with SimActive, and you're joining us for the webinar, 3 Ways to Speed Up Photogrammetry. And with me, I have my guest, Don Cummins, President of Air Data Solutions. Don, say hi to everybody.
Hello.
There you go. Now we're off and running. So, Don, I've worked at ADS, but not your ADS. I worked at the one in Oklahoma. Different companies, different times, but I love seeing the hat. That's really cool. So give us a little bit of information, background on yourself and your company.
All right. It's funny you bring up the Oklahoma ADS because we were probably in business 2 or 3 years when we first came across them.
Yep.
And I said, look at this company, they've got our name. And so I started doing some research on them and realized they've been around for much longer than I've even been alive. And so got connected with them a little bit over the years, and sometimes there's some confusion, but
Yeah.
our company, Data Solutions, so it's same initials, almost the same name.
Yeah.
And we're just happy to be playing kind of in the same ballpark.
Yeah, outstanding.
It's been a great journey. A little bit about ADS. I founded the company in 2014. It stemmed from what I call my prior life, where I was a ranch manager and raised cattle, worked in agriculture, and I really just wanted to fly airplanes, kind of for fun, and started taking some photos out the window of the planes of cornfields and bean fields and cattle pastures. And people started asking for these photos. And next I needed to figure out where I was, and I took the photos and brought in GPS positioning. And then I realized there was a whole new world involved with mapping and photogrammetry that I didn't even know about yet. So what started as a hobby turned into a business, which is still a blast. I still learn every day. I'm by no means an expert, but we've done pretty well over the last several years, and we're excited to see where it's going to go in the next years.
So, I mean, how many people do you have working with you?
Currently, there's about 15 employees with ADS. We have about 6 pilots full time. We also employ some contract pilots to help us as needed. And I fly missions myself, not as many as I used to. So I get to sit behind the desk a lot more and try to work up jobs and build relationships and do all that while the pilots are out having all the fun.
Right.
And then we processing LiDAR and photogrammetry, and all that's done right here in the office beside me. And we have an excellent team that's a whole lot smarter than I am, that figures out how to do all of that magic after the planes land.
Sure.
And then we also have office staff that handles all the books and everything else that goes along with it.
Ah, very cool. I mean, I kind of ended up in the business the same way. My dad was like you. He was, retired Marine, loved flying, built his own airplanes. And at some point he worked for an engineering company. He actually worked for Fugro in California, and led their mapping department at the time in California. And the guy that he subcontracted all the flying to was getting ready to retire. And he said to my dad, "Hey, you want to buy the company?" And he did. And 40 years later, I'm still here. So, yeah, I can understand the desire to fly and to do photography and geek out on imagery from everywhere in the world. So very cool. So what kind of planes do you guys fly?
We fly twin engine, single engine, piston aircraft.
Okay.
Also helicopters for leak detection and smaller, lower level photogrammetry or video jobs. Okay. But our main work are Aero Commanders, AC-50 twin commanders. Cool. We have 5 platforms right now that are carrying cameras, 4-band cameras, and terrain mappers and city mappers. So they do the majority of the work. And then we also have some single engine 206s, 182s that get tasked with all the jobs or the linear work.
Okay.
And they either strut mounts or small holes in them for the smaller cameras.
Okay, cool. So for everybody attending the webinar, before we get too deep into stuff, I just wanted to go over the topics. And the topics are going to be, and these all relate to how you can speed up your photogrammetry, but know your projects, planning and acquisition for those projects, and then processing to meet the requirements that your customers are asking for. So we can start with knowing your projects. And I mean, project types tend to determine what platform and what sensor you may own or may be using. Each one has its own sweet spot. Some are workhorses that can do everything. Some are, dedicated to specific missions, but, efficient acquisition speed, ownership cost, all those things play into what you're doing with your aircraft or your acquisition platform. So in general, I mean, what kind of projects do you guys get involved in at Area Solutions?
That's a great question. I wish I could give a general answer, but part of my problem is I have a hard time saying no.
That's
so
okay.
We projects that run from very small to very large, and we worked on statewide projects with 4-band mapping, statewide, countywide projects with LiDAR, and we have a bid out right now for a 20-acre timber tract, and so it is as large or small as they come. But like you said, matching the sensors with the aircraft with the job is critical. And it's worked for us to have a kind of a several different to choose from, because it allows us to be able to not only say yes but perform efficiently as well. And so if we can stack jobs together, then we can make the bigger sensors, the bigger planes work. But if we can't, then we try to get there as cheaply as possible on the smaller jobs and get it knocked out with a less expensive platform and aircraft. So a lot of thought goes into the planning and the logistics of who goes where, just to try to not waste time or cost on sensors that could be better used elsewhere.
Right. Absolutely. So, do you guys, I mean, so you kind of do everything. So you talked about leak detection, projects as small as 20 acres, statewide projects. So you kind of, like you say, you get your hands involved in everything. So, what are some of the typical challenges you might face with these projects? Like, for example, maybe not remote locations because you're kind of central. Maybe that's not a problem, but you've got things like access, you've got climate, you've got weather, how you're dealing with ground control, whether you need connectivity, all those things. What do you guys run into that are challenges?
Yeah. Well, the standard challenge is always weather, and you get to go. So I don't think I have to spend a whole lot of time on that. Either you have the weather for the collects or you don't.
Yep.
The other challenges that may or may not be unique to us, I'm sure everybody faces those. Like you said, is access and remoteness to some areas. We do fly as far as Hawaii to Maine to Florida, so everywhere in between. And sometimes being remote creates its own issues because you don't know if you have the ground logistics to support your aerial operations. You have to make relationships with people in those locations just in order to get the job done. And while it's a challenge, it's also a lot of fun because you get to learn different ways of doing things and meet new people, and they support you, and you in turn get to support them at some point as well. So that is a challenge as well. In addition to that is really the logistics of keeping the airplanes busy, but not overtasking them. I think is one that I juggle on a constant basis because we want to be responsive and quick and get the jobs done in a timely manner, which requires having a lot of equipment available, but we also don't want to have a lot of equipment available that's not doing anything.
Yeah.
So managing that aspect of it, and sometimes it involves reaching out by faith and saying, okay, we're going to invest in this and have it ready to go and hope that the work follows. Or sometimes it's we just have to push twice as hard right now and get through this
Yep.
because there's nothing able to come back and support it on the back end. So just kind of managing the demand with what's coming down the pipe and also keeping the schedules and we've really made, I guess, made a name for ourselves, which I think everybody tries to and does a really good job at it, despite all the challenges. But just not over promising
Yeah.
and hopefully over delivering and staying on schedule because we understand that our schedule problems are not our clients' schedule problems. They, if we get behind because of weather or maintenance or just poor planning or whatever it is, it doesn't really matter because to the client, what our problems are, they still need the data. So whatever it takes to get, and sometimes that means reaching out to some other people in the industry and asking them if they can step in and help just to get the job delivered on time. And we found that building relationships like that, they go two ways. We're not an island. We can't do it all ourselves. So bringing in some help from other companies, I don't see it as competition. I see it as we're helping each other out so that everybody can continue to grow and to get the job done and serve their clients. So those are probably some of the biggest challenges that we face on a day-to-day basis. Outside of just the standard keeping the airplanes, these old machines still in the air, and we've got an awesome maintenance department here and lots that we trust on the road.
Mm-hmm.
And sometimes keeping these things running is a big part of the challenge, but we're blessed to have, I call them miracle workers, that they somehow keep these things running. And then the magic of the sensors and everything as well. I don't always understand how they work, but when all the green lights come on and it starts collecting data like it should, to me that's magic. And I tell my crews to speak sweetly to the sensors because they respond to that. They don't respond well to you jerking the cables out and getting upset with them and everything. So just try to treat everything nicely, and that seems to help keep things running a little bit more smoothly.
Well, you brought up a good point a bit ago about our competitors, we would call them. They are all our peers. So, for example, when I was working in Southern California doing this, we all knew each other. We all knew each other so well that, we might be up in the air and we've been mobilized for 10 jobs that day and the day is getting short and we're not on site. And, we'll call out the tail number of the guys that, work down the street and say, hey, we can't get there in time. Can you pick up these lines for us? And, this was before cell phones and, anything. We just all knew how to take care of each other because you're right. The reality is, we're all ultimately working for the same engineers, the same people. And if as a group we can provide the data on time and efficiently to help them get to their answers faster, it's better for all of us. So that's a good point you brought up about teaming up and working together when you're stretched to your limits. So
Right.
very good point. So you mentioned a little bit about sensors, and I mean, you've said that you've got aircraft and helicopter access. I assume you have some drones.
We do.
Okay. So you've got the gamut of equipment. Obviously, you mentioned also that you have 4-band sensors. You have access to LiDAR. I imagine sometimes you're doing dual collects with those.
Yes, sometimes.
Yep.
One of our LiDAR systems has a 4-band nadir camera. The other has oblique cameras. So sometimes we'll collect, and sometimes it's just straight LiDAR. I'll say the dual collects have a lot more challenges than the straight LiDAR,
Yeah.
but they really save a lot of time and money as well if you can collect it both on the same swaths.
Yeah, and for maybe for some of our listeners or viewers, not all lidar units and cameras have the same acquisition swath. So you have a couple of options there. You can fly to fit the one that will accommodate both, or you can do, worst off, maybe a dual collect, or maybe it's easier to collect the lidar at night versus the imagery in the daytime. So there's all kinds of issues that come up with that you mentioned, but there's also a sweet spot for that too. So it's well worth having, and as the manufacturers start working more together, we're starting to see more cohesiveness in how they collect, and how those swaths get closer to each other, so that you don't have to do a dual collect. But I would imagine your decisions on buying sensors, just like it would be aircraft, are really dictated by the type of projects you guys get involved in.
It is. Yeah, the projects usually drive the acquisitions of sensors. Sometimes the sensors actually start off as a platforming project where the the client provides the sensor and we fly it, and then we see what it can do and what it's capable of, and if those type of projects increase, then we kind of have firsthand knowledge. Other times, it's just you build off of what you know. We've been using phase one cameras for many years, and we know what they can do and what they're good at, and that kind of pushes the types of projects that we go after because of that type of sensor. And so it's a little bit of both. You work with what you have and you grow that, but sometimes something comes in from left field and you have to go research and figure out what kind of sensor will work for that. And that's more the case with the leak detection. There's lots of technology out there for detecting leaks, and some of them work better in some environments and some instances and others. So
Mm-hmm.
we get right. So the helicopter that we use actually has a gimbal that's placed in the back seat of the helicopter, and it looks
Okay.
outside.
Mm-hmm.
Not a pod, but we do use pods on some of the aircraft. So I'm familiar with I think what you're getting at.
Mm-hmm.
We have kind of with our helicopter provider, and we use it for low level imagery, like stuff that you would normally use drones for,
Mm-hmm.
and we also use it for linear video work and leak detection. It's
Right.
kind of the sweet spot.
So you mentioned drones. So what, we're 12 years into drones now, I think. I think that's how long they've been around. Have you figured out what they're good for yet?
I would like to say yes. I use them for, and for what they're best at is jobs that we can't get to with the other platforms. Is in my experience.
Mm-hmm.
So our experience with drones goes back to 2014 or so, and it was really started flying airplanes first, and I just wanted to get closer photos of certain things that I couldn't get to with the airplane.
Mm-hmm.
So and then we started pushing drone services. We invested in some long range, beyond line of sight technology before that was really a thing. Put a lot of money into bigger multi-rotor drones, bigger sensors. And honestly, the pucker factor of flying a drone with an expensive sensor never left.
Yep.
And we did a lot of missions with these, and the goal always became, let's figure out a way to scale this to the airplane drones definitely have their place, and the jobs that they can do, only they can do. So finding that sweet spot between what makes sense for the aircraft, what makes sense for the drone, and not trying to force the other one into that location, I think is the key. And from a drone perspective, you can do anything with a drone. From an airplane perspective, well, we can do anything with an airplane. And I think marrying those two ideas and saying, all right, we each got a space. This one's sufficient here, and it makes sense to send a crew, spend a day on this location, and knock it out versus tasking an airplane to fly, and vice versa. Sometimes you'll see people trying to tackle a 10 square mile job with a drone that takes days, many days to fly, and then many days to process the data. And the imagery can be good, the data can be good, but if you're what we found with the imagery side of it is even if you have great conditions, it takes so long to collect that your sun angle changing throughout the day, and the difference in maybe a high overcast the next day creates a lot of additional processing problems that you have to deal with later, that if you could collect it all within an hour or two, you don't have to deal with. So those are kind of the extreme examples where we finally decided to kind of put each one in its box, and try not to force one into doing the job that's better suited for the other.
Yeah, and I asked that question tongue in cheek because drones do have their place for sure. They do create higher resolution images. They, like you said, they can go where aircraft might not necessarily go, or it's just more feasible to send a drone to do something. And I just think off the top of my head, if you've got a project out in the Caribbean, you really probably don't want to send your aircraft out there to wait and wait and wait and wait for clear skies to actually get something done. Whereas if it's small enough, the drone could probably do that for you. And they really do excel at small projects. I do agree with you. There's a huge pucker factor when you've got, $300,000 worth of cameras and LiDAR equipment underneath, an $80,000 gas powered drone. The mission becomes, let's finish this mission and get it back down on the ground.
Yeah.
Leave
as long as we're carrying these expensive sensors, there's always going to be a poker factor no matter what.
Yeah.
But asking them on the right jobs and making the drones pay for themselves is the challenge that I think we're getting there. The technology industry is maturing.
Yeah.
And I think it's getting there.
So, do you use them any of the methane detection or anything like that? Are you working on it in that way as well?
We actually started with methane detection with drones, handheld and drones,
mm-hmm.
and then we moved to helicopter because our projects got bigger, the corridors got long, and we were spending days and days out in the field flying these drones, and then access became a problem because on corridors, sometimes you have landowner issues where they don't want you on their land. You can only fly this thing so far. So our crews are spending time just trying to get to the spot so they could fly. And then dealing with unhappy landowners or
mm-hmm.
people who what you were doing, so they call the police on you, and having to try to sort that out. So we'd usually have an additional person on site just to deal with all the excess so that the drone crews stay focused on what they were doing. And there's a lot of concern, and people don't know what you're actually looking at while you're flying over their house, and it seems like you're spying on them. And we don't really care what's in the backyard of your house until you start wondering why we're there, and then we wonder why you care. So it's
good point. So let's talk a little bit about planning and acquisition, because once you've created your stall full of aircraft and sensors, based on the type of projects that you have. Now, as you said, you got to start looking at them for, how am I going to capture this information in a way that it will be efficient to process, because processing is still a big chunk of, or the biggest chunk of your project that's time consuming, and you want to minimize that amount of processing time. I remember not long ago where you would flip your images from RGB to black and white just because they're smaller file sizes and you could run them through faster. This is not the case anymore, but it was an option. So, talk about a little bit about, how you determine, how you look at it when you're setting up a project to make this thing the most efficient to bring into whatever software you're using.
Yeah, that's a great question, because so much planning goes into the processing end of it. We of course want to keep our collection times down as low as possible, but sometimes we pose two scenarios. Do we want to spend longer collecting and less time processing, or do we want to spend the vice versa?
Yeah.
And if in some instances, and we've had sometimes where we tried to cut too hard on the collection side and we suffered on the processing, and either had to spend a whole lot of extra time or else go back and refly it. So we do push that to the limits, or we try to, so that we know just how far we can go. And like you said, if you can make the file sizes and the photos smaller, sometimes that helps as well. Some clients will accept that, some will not. And so looking at all factors in the beginning helps us determine not only how long is this going to take to collect, but approximate schedule on the processing end as well. And what we've kind of found over the years is when we first started this, before SimActive, we used Structure for Motion software, which required a lot more overlap and longer processing times, as well as longer collection times. So when we moved to SimActive Correlator for our main processing software, we were able to cut our collections in half or more. And at first it was concerning because that was all that we knew. And we thought, how in the world can this do as good of a job? Until we started getting experience with it and seeing that, yes, not only can it do as good of a job, it can do a better job. And it's really industry standard. It's accepted practice to fly 60-30 and 60-40 if you're in terrain or something that you got some building lean or whatever it is that you want to collect a little more overlap. So now the only time we have to increase overlap is if it's either terrain or very urban areas with lots of tall buildings and bridges and things that you just need those extra looks. So the ability of the software to kind of help us be flexible in how we collect really helps us and being able to quote these jobs specifically based around what the deliverables are. So on the planning end, typically we're shooting 60-30 on most projects, and we can use the 4-band, the 3-band. Sometimes it makes sense to chop it up and process 2 separate 3-band data sets instead of going straight with the 4-band, because the client wants color infrared instead of 4-band. And it's very nice to be able to use that same AT and that same DSM that's created from the initial processing and just dump in the color infrared images and run a new mosaic. So
yes,
that SimActive brings saves us a lot of time if we go that route. And it's definitely something that we consider on the front end when we're quoting those projects.
So a couple of things you mentioned there. So obviously, right off the bat, when you're talking to your customer, and they say, well, I need this level of detail on my mapping. You're the one who knows, at what resolution or what ground sample distance will meet the accuracy requirements that he wants. And sometimes they've just heard they can get super high resolution stuff. And then they don't realize that, well, there's a cost to that. And if you really want that, I can give that to you. It's going to exceed your accuracy requirements. So do you really want that? So I think that is a big part of speeding up your photogrammetric processing, knowing exactly what your client wants and helping educate them on how we get to that solution.
Right.
The other thing you talked about was the type of project. If you're doing urban areas or areas where you've got a lot of building lean or a lot of elevation, then you're probably going to want to have more overlap just to cover yourself when you're trying to make, for instance, those models, that clean orthomosaic, what have you. But if you're out in the middle of nowhere, go back to the 60-30 rule. And I had this question from somebody doing emergency response just recently that said, hey, we want to process our data faster. How can we do that? And my question was, well, how much, overlap and side lap? Your question is 80-60. I'm like, why are you doing that? You don't need to do that. So, go back to the golden rule of photogrammetry, 60-30, 60-40, whatever, but it's fewer images, and every image takes an amount of time to process. So the more you can reduce that number, the better off you are. And you're right. SimActives have been around a long time. It's based on photogrammetry as opposed to structure from motion. So, we can work with less overlap. Our AT solutions tend to work better. And again, that just means faster processing. So other than that, I like what you said about being able to capture, multiple bands and, process out the RGB and then just drop in the other band later on, because it's already been processed. All you have to do is make mosaics out of that. The AT, the camera solution's the same. The AT solution's the same. You can cut some time out. And people learn this as they start working with our software or anybody's software. How can I make this more efficient? How can I not shortcut the system, but come up with ways to do this faster? And there certainly are ways to do that. I talked about, back when drones first came out, the camera wasn't associated with anything controlling it except for a firing sequence, and it would go off, every X amount of seconds, whether you were in a turn or not. So sometimes you'd end up with 30% more imagery because it kept all the images in the turns. And, eventually people figured out how to kick those out and, or the software eliminates them. So it makes it faster. Less images is faster.
There's, there's some, when you're thinking about how much overlap is required, 1% is technically all that's required. And we've proven this many times by doing corridor work where there's on the side, we have forward overlap, but it can still create a linear mosaic that's accurate on flat line. So if you have any overlap at all, SimActive is usually pretty good about tying those lines together. And we do projects as well where no overlap is desired because we're counting objects or animals.
Yeah.
And if you count, so we do push the overlap to the extreme on the other end. Sometimes when we're not doing technically mapping and photogrammetry, we're actually trying not to overlap, and being able to use the minimums possible really helps us save time on that end of the spectrum when we're trying to reduce those doubles. So it's very useful to have that kind of flexibility in the photogrammetry process, that you can pretty much use it to the fullest extent possible.
Now, are you finding that when you're doing the dual sensor collect with LiDAR, then I would assume you're using the LiDAR as the surface for the project, rather than having the surface created through the DSM process?
It depends. Sometimes yes, sometimes no. Either the photogrammetry derived surfaces. Sometimes we'll bring in third-party surfaces,
Mm-hmm.
and some LiDAR, but it really just depends. A lot of times our LiDAR surfaces are so dense uh,
Thin them.
we have to in order for them to work as a DSM. And as long as things line up like they should, there's times where we can actually process our LiDAR separately, process in some active the imagery to control, put it on top of the LiDAR, and it matches up perfectly. And you know, that's what's great about seeing those things line up when they haven't been part of the same project together, is we know the accuracy in the photogrammetry process because we have a double check. We got the ground control, and then we have the additional data set, and everything marries up really nicely. So
Yeah.
you can, whichever way is either the fastest or makes the most sense or creates the best model that we're looking for.
Right, and then you're aware in correlated 3D, you can always bring in the LiDAR afterwards and then colorize it from the ortho mosaics.
Right.
Yeah.
Yeah. That's something we haven't done a whole lot of yet, but I've seen the tools for it, so that's something we probably need to dive into a little bit more in depth once we have some breathing time.
Yeah, it tends to really impress the clients because they're not used to looking at classified point clouds or just point clouds with nothing, say an intensity image. But when you throw in the color value as well, then they can say, okay, now I can see the bulldozer, I can see the power line, all that stuff. So it's a pretty nice little add, for the end user. But so. One of the things you asked prior to us jumping into the webinar, you and I were chatting and we were talking about speeding up the workflow, and you jokingly said one thing to speed up the workflow is for correlated 3D to speed up the workflow. And sometimes your wish comes true, and we're going to talk here a little bit about what's coming up in our next release. Which will happen sometime in the week or so. But in doing so, I'm also going to do a little bit of demo and talk about, from my perspective, how you might speed up your workflows or how you might avoid some pitfalls that will slow you down. Might be more important. And we're going to talk about the different automated tools we have within Correlated 3D. So, we've got some scripts, we've got some built-in workflows that you can use. And then for those of us that are more involved, the step-by-step processing, the workflow that we normally do. You and I have chatted about the notifications, and just having those notifications when a process ends, like you say, you kick this thing off, it goes on overnight. It'd sure be nice to know, at midnight that it finished processing and it's on to the next step. And we do offer that as well. But for me, I'd like to thank you for your time. I'm not going to have you sit through the demo with me because you've got things to do. But I just, again, wanted to say thank you for your time. You and I met personally at MAPS this summer for the first time, which is an association of us peers in the business, as we talked about earlier. Have you got any final thoughts?
Well, I would like to say the same thing. Thank you for your support of our business, because SimActive is constantly coming out with updates, and every one of them is valuable. It's not always like the Apple updates where it's like, does that really do anything? Fix minor bugs and that, what does that even mean? But your updates are very valuable, and I appreciate all the work that goes on behind the scenes. And then the support, just you reaching out when we're up at MAPS, meeting, talking, what's going on. Is there anything we can help you with? That's something that we don't see a whole lot from software manufacturers. It's pretty much use our software. It's as good as it can get. If you have a problem, it's probably all. So, the difference with working with you all is that we use that support, we expect it, and we get it. And I appreciate that. It's helped us to grow a lot as a company.
Well, Don, thank you very much. I'll go ahead and jump into the demo side with everybody, but thanks again.
All right. Thank you. Pleasure to be here.
Let me get Correlator 3D up and running. Okay, so here we have a small project, just a UAV project, so that we can go over this together. But some of the things I wanted to talk about, how you can predict issues when you're working with data sets. So, clearly the idea is to, load in a project, run it all the way through, everything comes out great. That's the way it should be. But we all know that depending on the terrain and other factors, there can be things that limit or require manual editing in the process. So let's look at some of the ways we can detect this. And one of the first things to predicting issues is once you load all your images, before you start anything, make sure that your reference or your online data is on. So here we have a baseball field. We've got flight lines going through it, as you can see, flight lines in this area. And we can look at it and say, okay, where would we likely see issues? And you know from working in the drone world that we're at a lower altitude. I think in this one we're like 300 feet. And for imagery to work, for the tie point matching, you need to have features within image pairs for the data to tie to. So where we want to run into problems typically would be over water or over dense vegetation. So here in this corner, there's not a whole lot of water. We should be okay. But over here, we've got an area where there's probably going to be some vegetation issues with those tie points. Now, obviously, ways to resolve that is to fly higher so you capture more image footprint with more variation, but sometimes we don't have that choice. So, and I say this because before someone runs through an automated routine, you need to see these things and mitigate them or manually process to get to a good solution. You don't want to put a 17,000 image project in here, run the automated routines only to find out X hours later that there were some errors in the data set caused by the way it was collected. So if we look at, for example, if we just go into the AT, in this example, the first thing is to say is tie points are required. So the answer is yes, we're going to run tie points. And we'll go ahead and run standard tie points. You could run exhaustive if you want. That might tighten it up a bit. So that's an option. But we'll go ahead and process it. And here you can see, just as we suspected, that there are some issues with tie points in this vegetation. Not such a big deal in this project, but again, if you're doing something large and you're going over a forested area and you're at a low altitude, you may see some big gaps in that data. So right away here, you know that most likely if you were to run the automated processes, or even if you were just to go through the steps here, once you created your DEM, you'd probably have some anomalies in here. Now, is that important? That depends on what your deliverable is to your customer. But we can go ahead and fix this. And all we have to do, again, we could have run an exhaustive tie point extraction, which may have helped out there. But we can also just go in and add manual tie points, creating links between images. So what we would do is we'd say grab this image and go to this image. And as you can see, there's not a lot of variation and there's not a lot going on here, but we could probably zoom in into this area. And let's see, let's zoom in. And I'm guessing I can find something. Let's take one maybe right here. And let's go over here and we'll zoom out a bit. I'm just doing this to get the software to acknowledge where we're at. Okay, so right now we've got two images, and let's go ahead and See if we can get to the edge. Yeah, here we've got the edge, and we've got the edge over here. So we're probably in this area here, and I can probably make an estimation that there's a point here. Now again, these just have to be rough. It just has to be rough so the software has something to put together. And we'll go ahead and save, and then we can zoom out again. And you can see we've created a connection between the two. And now as we move the cursor over points, we're going to start to see some matches. Now, again, this is an area of vegetation. It doesn't have to be that great, but I can look in here and I can say, well, you know, there's this and this look pretty much the same. Now, granted, this is in Florida, so every once in a while you can catch palm trees, you can catch things like that, that maybe the imagery is not going to find itself. But clearly you could tell these are the same tree. All I'm trying to do is create a better surface in this area, you know, where I won't have a deep hole or a dive or something like that. So again, we'll hit save and we'll say that's good enough. And then maybe I'll go over here and I see some stuff going on right in here. Maybe something there that I can match and call similar. And when you do this, you always want to at least get 3 points. And I'm going to say, now again, these palm trees are blowing in the wind. I know that. I'm just trying to get close. We'll go ahead and save and close. We'll close this window. And now we've got a connection between these two. Now I could keep going through each one and tighten this up. And I will tell you that if you do create a connection between two, sometimes it'll go ahead and fill those gaps. So that's an option as well. But I wanted you to see this because before you go to run, again, an automated process all the way through, you're going to want to make sure that these type of things are cleaned out. So we've looked at our reference imagery, and our reference imagery tells us that there's probably going to be an issue in this area. So you always want to do that when you set up a project. And then the next thing you can do is in the AT process, you can go ahead and create those links. Once you're done with creating those links, you can step out of that and then go ahead and perform the bundle adjustment. So, and then once you've got the bundle adjustment, then you can go ahead and move ahead with the rest of the project. So let me step out of AT real quick. Okay. Now, another step you could take if you wanted to is just to go ahead and create a course DEM. So if we run that, it's just created a course DEM of the area for us to work with, okay? And we can scroll through here. And what we're really looking for is, are there any spikes down here? And, you know, again, on something that's, you know, under 100 images, no big deal. But when you're working with 17,000 images, 20,000 images, take the time to perform these steps before you just run something to process overnight. Okay, that's very important. But right now, I mean, for the most part, this looks good for what we would use it for. So again, that's a check. I've got a course surface and I could work with that. Now that we know our data looks good, okay, now that we know that we've got the coverage we want, that it's going to, the AT is processed properly, and that we don't have any holes in our surface, that we've mitigated those holes, we could look at other steps. Okay, so we'll go out of AT, and the next thing I would like to talk about is, now that this is all good, you could run automated workflows. And let's talk about the automated workflows and what we would use them for. Again, on a small project, not such a big deal, but if you're running 17,000 images, you might want a quick project overview running automated workflows. So automated workflows are just templates of scripts. And remember that Correlated 3D can be run script-based. It can be run command line, so you don't even have to open up the GUI if you don't want to. But we've created some script templates. The first one is the classic photogrammetric workflow. So again, if you're going to produce a product with outputs that you would deliver to the client, this is most likely the workflow that you would take. Now you can do it manually, or you can do it automated. Classic photogrammetric workflow, typically you would not run the automation on because you're going to tweak it as you work with it. But quick project overview, you might want to run. And again, the larger the project, the more likely you're going to be to just say, hey, I'd like a quick overview of this. And if the data set looks good, like as we said before, there are no holes in the data set, it's worth running. So quick project overview, what it's going to do is generate all outputs at a coarse resolution. So think of this as, you've just captured imagery for emergency response. You're still in the field, you're back in the hotel that night, and you want to validate what you've captured. You want to say, have I got complete coverage? Do I have any holes in my data set? Am I missing images? That kind of thing. So you could run quick project overview. And what it's going to do is it's going to do the basic AT, okay, which we've already done. It's going to create a coarse DSM, which we did in the AT process. The vertical accuracy is not important, so run it quickly. It's not going to generate a point cloud. It's not going to generate a DTM. And it's going to go ahead and ortho rectify it at a coarse resolution, so not your highest resolution, but it is going to crank this out very fast for you. So you would want to do this if you were doing a quick project overview. And you'll notice that these fields change as we go through these templates. The other option you might want to go with is a fast ortho. Okay, so this is going to generate a coarse DEM, but it's going to create the ortho at the optimal resolution. And you can see that what it's changed here is these remain the same, but down here it says the resolution is optimal. Again, another way to get a quick deliverable so you could run this process to get to a faster result. So another thing I want to point out for you is that, let's go back to the quick project overview. You could run the whole script. However, as I said, we've already run the AT. So we can just go ahead and say, run this as is. And so here we have our completed mosaic using the quick project overview. Another thing I wanted to bring up, especially when you're working with large projects, is our notifications. So here under general settings, if you don't have this set up already, you can go in and create email notifications. So if we look at mine, you put your server information in, your credentials, your password, all of that. But here you can look at, for recipients, I have two recipients. I have my email address, and I also have the email address that's associated with my phone. And that allows me to get text messages as well. Now, again, small projects, not such a big deal, but you can have the email notifications notify you after every step, or you can have the notifications notify you after completion of the project. Me personally, when I'm working on large projects, I want to know as each step is completed. And if you think about it, when you're running scripts, if I go with, say, fast ortho, okay, maybe I only want to run the script through DSM generation, and then from there I want to stop and inspect the DSM. Then I would turn off these features. I would run the process, and the notifications would tell me when the AT is done and then when the DSM is done. And then I know that I could log in remotely, take a look at the results, edit them if I need to, and continue on with the processing. So that's the nice thing about notifications. Now, everything I've shown you here in the automated workflow can also, of course, be done manually. We've already looked at AT, and it's laid out left to right in the mapping workflow. So after AT, you would go ahead and create your DSM. If you needed a bare earth type surface, then you would create your DTM. If you needed to do any editing, you would edit in DEM editing. After that, you would produce your orthos. And then from producing orthos, you'd create your mosaic, and you'd have mosaic editing capability. And then on the back end, if you also needed a model, you could create your models right here as well. Those can all be done in the automated workflows, but they can also be done manually. And to be honest, when projects get big, you kind of want to have your eyes on through each step. So the manual process is probably the better way to go, or just turning off features in the automated workflow so that you're guiding it through each step. So keep that in mind. And then the last thing I wanted to mention, and we're really excited about this, is that in version 10.1, we have doubled, that's right, doubled our DSM processing speed. So as most of you will know, the generation of the DSM is probably the longest portion of the overall workflow. So the fact that we have now doubled that is creating some very impressive speeds. And I can tell you, even on our side, on the support side, we're blown away at how fast this thing is going. And that's not with using distributed workstations. This is working off of just one workstation. So if you have not upgraded to 10.1, it is available, and certainly go ahead and update to that. You will definitely see an increase in your overall processing speed. So take a look at that. So that's it for the webinar. I want to thank everybody for joining us, and of course thank our guest Don Cummins. This webinar, as well as all of our other webinars, is available on our website, simactive.com, under the Learning tab. Thanks again for joining us. Until next time.